Hello everybody. So today's objective, we're going to be solving problems involving elevation and depression. So notice that we're talking about angles of elevation and depression. So one of the first things that we're going to actually get to know first and foremost is that the angle of elevation and the angle of depression have equal measures. Well, why is that? So let's talk about that. One of the examples that we're looking at here has to do with a building. So if we're looking at a building and we're standing at the very top, we're going to have to look down. And then if we're standing at the bottom, we would have to look up. So these are some of the concepts that we're going to have to actually make sure we're keeping track of. Are we looking up? Are we looking down? Like, what is this that's going on? So for an angle of depression, and some of you remember this means down. For elevation, this would actually mean going up. So let's go ahead and talk a little bit more about this. Okay, the way you would actually do this is, and I'm going to just kind of give an example here. So if you were to be standing right here and look straight ahead, to look at what's at the bottom, you would have to look down. So you would have to actually move your eyesight from there down. And that would be the angle of depression. The other way would be if you're standing at the bottom and you're having to look up. So then your angle would be elevation because you're looking up. I want you to notice something that's happening here. You have two parallel lines. So you have a parallel line down here at the bottom to the line up here at the top. That's going to cause your two parallel lines. So you're going to start to see something here, I hope. So you got two parallel lines. Let's go ahead and make that a note. We're going to go ahead and call this letter A, and this one down here is letter B. So line A is parallel to line B. So you have two parallel lines. Do you see what this is right here? That little diagonal right there, that should remind you of, ta-da, your transversal. So we're going to go ahead and highlight this guy right here because that is our transversal. And we're going to go ahead and label it now. So this is the transversal. Boom! So now we have two parallel lines being cut by a transversal. At this point, you should be remembering this little teeny tiny thing we call ABBA. So we're going to go ahead and label our angles using ABBA. So A, B, B, A. Notice that X and Y are both labeled B, which means they're both congruent. That should be something, boom, you should remember. So you should make a note. And we're going to make a note right here. Angle Y is congruent to angle X. And we're going to make a note right here. Both labeled B. That should be something that sticks. Both are labeled B, so that means both of them are congruent. We did this in the past. The next thing you're probably wondering is, well, what does this have to do with SOHCAHTOA? Because we've been doing this. Well, normally we use this type of thing if we have really tall objects that we just cannot measure because they're just too tall. and we don't have enough measuring tape. So little things like this. So a lot of the real world problems that we have involve looking to the top or looking down to the bottom for an object. So we're going to be able to use angles of elevation and depression to be able to figure out how tall something might be or how far away something is. Just a few things that maybe would come to mind when it comes to this type of measurement or calculation is, you know how you're looking at a role-playing game, an RPG? You get a lot of realistic viewpoints because you're already having people that are doing this type of calculation for you. So they're able to sit there and mimic the actual angles of elevation and depression. So this is actually used a lot as far as like when you're looking at virtual reality, and the scope of like actual construction and architecture. You have these measurements being calculated by the use of SOHCAHTOA. So this is used in the real world a lot. Are you always given a drawing? No, it's not always going to be that easy. We already know that. So we're going to actually have to do some reading and then some drawing so we actually understand what is going on. So we're going to start reading and take it step by step, break it up. So if you notice, at a point on the ground, 39 feet from the foot of a tree, there's a comma here. I'm going to stop right there. So I'm going to draw this at a point on the ground. So I have the ground. I'm going to use this down here as my ground. I'm going to put some grass just to make it like, you know. If I have to, I'll put a little flower right here. That way I know that's the ground. Okay. In fact, I'm going to use that as my point right there. At a point on the ground, 39 feet from the foot of a tree. So I have a tree over here somewhere. So I'm going to go ahead and draw my tree. And most times, if you have a chance, this is where go ahead and doodle. You know that it's 39 feet away. So here to here, it's 39 feet from the foot of the tree. Go on. The measure of the angle of elevation. This right here. Remember, elevation means up. So that means I'm going to be going up. The measure of the angle of elevation of the top of the tree is 42 degrees. So you're going to be looking up 42 degrees. This way. Remember, a tree and the ground should ideally form 90 degrees. So I'm going to put my little square right there to say that's 90 degrees already. Find the height of the tree to the nearest foot. So this right here is my X because I don't know how tall the tree is. And then you're going to go back and you're going to remember how you label your triangles for SOHCAHTOA. So this is my angle right here. I'm looking at this here. So this angle is facing this side. So that means this is my opposite. So X is my opposite. If I'm looking at the right angle, then that means that my right angle tells me that this is my hypotenuse. Which means the leftover is my adjacent. So my leftover side on this right triangle, this is my adjacent. And I'm going to go ahead and just abbreviate that way. I'm not spending too much time on this. So I do have my opposite and my adjacent. Opposite and adjacent. Those are the measures that I do have labeled. So remember, SOHCAHTOA. So I'm going to write that right here. SOHCAHTOA. I have opposite and adjacent, so that means it's this. It's TOA. So I'm going to need tangent theta. Remember, theta is the angle, and that's opposite over adjacent. Do I know my angle? Yes. So tangent 42 equals my opposite is x My adjacent is 39. And then go solve. Okay, so hopefully you go ahead and multiply by 39. Multiply by 39. Remember, you're trying to get rid of that denominator. So 39 times tangent 42. And then that's going to give you x. So after you plug this into the calculator and you calculate, you're going to get x is about, and I believe I got like 35. Yes, I did. I got about 35.1. And don't forget, this is being calculated in feet. So 35.1 feet. So now you're going to go ahead and write out your sentence stem so that way you got your answer. So the tree is about 35.1 feet tall. Boom. And now you just found out how you can use SOHCAHTOA to find the height of an object that is really, 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 really tall. Alright, so now we're going to go ahead and take it the other way. We're going to find out the angle of depression, or use the angle of depression. So, again, we don't have a picture, so we're going to have to do some drawing here. So again, from the top of a lighthouse, 165 feet above sea level, there's a comma right here. We're going to go ahead and break it off right there, and then we're going to go ahead and draw. We'll be right back for the drawing. Okay, so it's 165 feet above sea level. And remember, it says from the top of the lighthouse. So there's the top right there. And then you're going to go ahead and use the next piece that says the measure of the angle of depression of a boat at sea is 35 degrees. All right, so we have a boat way out here on the water. So we're going to go ahead and draw that and label our angle. Don't forget, please do not forget that depression means going down. So that's why you want to label this angle right here going down is 35 degrees. Remember, you have two parallel lines. So you have a parallel line up at the top, way up here, and this parallel line, which is the ocean. So if this is 35, that means this right here is 35. Remember, elevation and depression are actually the same thing. It just depends on which way you're going. So you have an angle of depression that is 35 from the top of the lighthouse down to the boat. So you're going to find to the nearest foot the distance from the boat to the base of the lighthouse. So you do not know from the boat to the base of the lighthouse. You do not know this distance right here. This is your X. And as always, the lighthouse and the water should ideally make a 90-degree angle. So here we go. We're going to go ahead and solve. Remember, keep in mind that you are using SOHCAHTOA because you're talking about distances using right triangles, or angle measures using right triangles. So we have this angle here, and this is looking at this right here, which means that this is the opposite. So again, opposite. And then you've got your other piece from the right angle going over, which is your hypotenuse. And then your leftovers is your adjacent. So this is the adjacent. So now you label your entire triangle. You have this angle, and it's looking, your measures that are given are this 165, which is opposite. So you have opposite and adjacent. And as always, you're going to use SOHCAHTOA. So don't forget, write it out. If you don't remember, SOHCAHTOA. The more you write it, the more you're going to remember it. So you have opposite and adjacent, which means it's this right here, which is the tangent. Are you always going to use tangent? No, not always. So make sure you keep that in mind. So tangent theta equals opposite over adjacent. You know the angle is 35. Your opposite is 165. And then your adjacent is the x. Dun, dun, dun. So now we have to solve this because we have our x in the denominator. So, like we've done before, you're going to go ahead and multiply by the denominator. So that's going to give me x tangent 35, x times tangent 35 equals 165. And you're going to divide by tangent 35. So that way you can get the x by itself. So x is equal to 165 divided by tangent 35. Boom. Go do this on the calculator. We'll be right back. Alright, so you should have done the calculations on your calculator. And you should have gotten that x is about 235.6 feet. Now it says find to the nearest foot. So that means this is actually further rounded down to 236 feet. So the boat is about 236 feet from the base of the lighthouse. Done. And that's how you use SOHCAHTOA with angles of elevation and depression. Good luck. Have fun. Fly, birdie, fly.